Hello everyone, my name is Garima. Welcome back to my YouTube channel, Crack CSA Exam with Ease. I hope you found my previous video. In today's video, we solve a previous year question from January 2026 physics exam. So, let's get started with the question number 11. An object move in a uniform circular motion with a radius of 0.1 meter and time period of 5 seconds. The linear velocity and the angular velocity of the object during motion are respectively. Here, the object is moving in a uniform circular motion and the radius is given as 0.1 meter and the time period is 5 seconds. So, we know that angular velocity omega is equal to 2 pi by t, where t is time period. We will put the value of t, that is 5 seconds, and we will get 2 pi by 5, which we solve this and we will get zero point 0.4 pi. And for calculating linear velocity, v is equal to r times omega, where omega is angular velocity. Then we will put the value of r, which is 0.1 meter, into omega, that is 2 pi by 5. And when we solve this, we will get 0.04 pi. So option D is correct. Question number 12. The graph of displacement of toy car moving in a straight line changing with time t is shown in figure. Which of the following statement is correct? Within 0 to 5 seconds, the average speed of toy car is 0.5 meter per second. We know that average velocity is equal to total displacement by total time. Here time is given as from 0 to 5 seconds. So when the object is moving from 0 to 4 second, the total distance is 4 second. When object is moving from 4 to 5 second, it is covering distance of 4 meter. So total distance will be 8 meter and total time is 5 second. So it will be equal to 8 by 5, which is equal to 1.6 meter per second. So option A is incorrect. Option B, within 0 to 4 second, the displacement of toy car movement is 8 meter. Since time is given 0 to 5 second, here the displacement or the distance covered by object is 4 meter, and in option it is given as 8 meter. So this option is wrong. In option C, within 4 to 5 second, the speed of toy car is 0.8 meter per second. So from 4 to 5 meter, 4 to 5 second, object is covering a distance of 4 meter. So distance is 4 meter and time is 1 second. So speed will become 4 meter per second. So this option is also wrong. Option D, within 0 to 4 second, the speed of toy car is 1 meter per second. So speed is equal to distance by time, and the distance covered by object from 0 to 4 second is 4 meter and the time is 4 second. So the speed will become 1 meter per second. So D option is correct. Question number 13. When an elevator accelerates vertically upward with the acceleration of 2 meter per second, the force exerted on a floor by a person with a mass of 50 kg inside the elevator is, here G is given as 10 meter per second square. We know that here N is normal reaction and mg is gravitational force, and the elevator is moving upward with the acceleration of 2 meter per second square. We know that F net is equal to mass times acceleration. This will become N minus mg is equal to ma, and N will be equal to m times g plus a. We will put the value of mass, that is 50 kg, acceleration due to gravity g is 10, and acceleration of elevator is 2. So when we solve this, it will become 600 Newton. So option A is correct. Question number 14. As shown in the figure, an object with a mass of 1 kg slides to the right along a horizontal ground. Given that sliding friction force acting on the object is 3 Newton and g is equal to 10 meter per second square, the coefficient of dynamic friction between object and horizontal ground is. Here N is the normal reaction, mg is the gravitational force, and these two forces are balanced, and friction force is in the opposite direction of motion of the object. we know that friction is equal to mu times n. Here normal force is balanced with the gravitational force. So n will be equal to mg. We will put the value of friction force, that is 3 Newton, and mass is equal to 1 and g is equal to 10. Then we will get mu is equal to 3 by 10, which is 0.3. So option C is correct. Question number 15. On a smooth horizontal surface, a constant force F is applied horizontally to a stationary object with a mass of 1 kg and magnitude of its change within 1 second is measured to be 10 meter per second. Therefore, the magnitude of force is, here mass is given as 1 kg and initial velocity of object is 0 and time is 1 second. The final velocity is 10 meter per second. So we know that for calculating force, acceleration is required, and we can calculate acceleration. A is equal to final velocity minus initial velocity divided by time. So we will put the value of v, that is 10, minus initial velocity is 0 divided by time, that is 1 second, and we will get acceleration is equal to 10 meter per second square. And in equation F is equal to ma, we will put the value of mass, that is 1, and acceleration is equal to 10. We will get force of 10 Newton. So option C is correct. Question number 16. When a light enters a medium from air with an angle of incidence I is equal to 60 degree and angle of refraction is R 30 degree, if the refractive index of air is 1 and the refractive index of medium is, according to Snell's law, we know that n1 sin I is equal to n2 sin R. Here n1 is the refractive index of first medium and n2 is the refractive index of second medium. So nm is equal to na into sin I divided by sin R. We will put the value of I, that is 60 degree, and R, that is 30 degree. Then we will get sin 60 is equal to root 3 by 2 and sin 30 1 by 2. Then when we solve this, we will get refractive index of medium is equal to root 3. So option D is correct. Question number 17. A small ball is in uniform circular motion with the angular velocity of 10 pi radian per second. The distance between the ball and the center of the circle is 1 centimeter. The centripetal acceleration of the ball is, here omega, that is the angular velocity, is given as 100 pi radian per second. Radius is given as in centimeter, so we need to convert that into meter. So 1 centimeter is equal to 0.01 meter. Centripetal acceleration is r times omega, where omega is angular velocity. We will put the value of r, that is 0.01, and omega, that is 100 pi. And when we solve this equation, we will get acceleration is equal to 100 pi square meter per second square. So option D is correct. Question number 18. As shown in the figure, a spring oscillator performs a simple harmonic motion between A and B, with O being the equilibrium position. The distance between A and B is measured to be 1 centimeter and the ball completes 5 full oscillations in 60 seconds. So here the motion of object is between A to B point, which is given as total distance AB is equal to 1 centimeter. So amplitude, that is the maximum displacement from the equilibrium position, that is O, will be equal to half of the AB, that is equal to 1 by 2, which is equal to 0.5 centimeter. Here the 5 oscillation is completed in 60 seconds. So frequency will be 5 by 60, which is 1 by 12 hertz. And the time period is 1 by frequency, which is 1 divided by 1 by 12, which will be equal to 12 seconds. That means in 12 seconds it completes one oscillation. So when the particle is starting its motion from equilibrium position, that is from 0, it move to B point, then return to A point, and then move back to O point. Then that means it completes one oscillation. So in 12 seconds, object is covering 2 centimeter distance. So in 1 second it will cover a distance of 2 by 12 centimeter. So in 3 seconds it will cover 2 divided by 12 into 3, that is 0.5 centimeter. So option D is correct. Question 19. An object with a mass of 50 kg moves horizontally towards the right at a speed of 10 meter per second. The momentum and kinetic energy are respectively. Here, the mass of object is 50 kg and velocity is equal to 10 meter per second. So we know that momentum is equal to mass times velocity. We will put the value of mass and velocity, which is 50 into 10, which is equal to 500 kg meter per second. And the relation between kinetic energy and momentum is, that is, kinetic energy is equal to p square by 2m. We will put the value of p, that is 500 into 500 divided by 2 into mass, that is 50. So when we solve this, we will get 2500 joule. So option B is correct. Question number 20. If a water droplet with a zero initial velocity falls from 5-meter height eaves, excluding air resistance, the speed at which water droplet falls to the ground is, here g is given as 10 meter per second square. So the drop is falling from the height of 5 meter. Initial velocity of the drop will be 0 and the total displacement of drop will be minus 5 meter and acceleration will be minus 10 meter per second square. Now we will use third equation of motion, that is v square minus u square is equal to 2 times acceleration into displacement. V square minus u, which is 0, is equal to 2 into acceleration, that is minus 10, into displacement, that is minus 5. We will get v square is equal to 100, that is the final velocity will become 10 meter per second. So option B is correct. Question number 21. A wooden box is pulled by a force F is equal to 50 Newton at an angle of 37 degree to the horizontal direction, which causes it to move a distance of 10 meter on a horizontal surface, given that cos 37 is equal to 0.8. The work done by the force F on the object. Here, force is given as 50 Newton and S, that is displacement, is equal to 10 meter. We know that work done is the dot product of force and displacement. So, and the angle between force and displacement is 37 degree. So it will become F cos 37 into S. We will put the value of F, that is 50, and cos 37, that is 0.8, and S, that is 10. So when we solve this, we will get work done is equal to 400 joule. So option D is correct. Question number 22. A simple harmonic transverse wave propagates along the positive direction of x-axis with the wave velocity of 10 meter per second. The waveform at t is equal to 0 is shown in figure. Which of the following statement is correct? Here, lambda, that is the wavelength, is the distance between two crusts or two troughs. So here, lambda will be equal to 10 minus 2, that is 8 meter. And time period is equal to wavelength divided by velocity, which is equal to 8 divided by 10. So it will become 0.8 second. And amplitude of the object is given as 6 centimeter, which is the maximum displacement of the object from the equilibrium position. So in one complete cycle, the distance covered by a particle is 4 times of amplitude. So in 1 second, the distance covered by a particle will be 4 times a divided by t. So in 0.6 second, the particle will cover a distance of 4a divided by t into 0.6. Here I am using unitary method. Now we will put the value of amplitude, that is 6, and time period, that is 0.8. And when we solve this, we will get 18 centimeter. So in option D, within 0 to 0.6 second, the particle has traveled a distance of 18 centimeter. This option is correct. Question number 23. Two electrical resistors have a resistance 3 ohm and 6 ohm respectively. Which of the following statement is correct? So here two resistance R1 is equal to 3 ohm and R2 is equal to 6 ohm is given. We have to find the equivalent resistance in parallel and in series, and we know that in series equivalent resistance is equal to sum of the resistance, that is R1 plus R2, which is equal to 3 plus 6, and it will be equal to 9 ohm. And in parallel the equivalent resistance is equal to that is 1 by Rp is equal to 1 by R1 plus 1 by R2. Then we will put the value of R1 and R2 we will get 1 by Rp is equal to 6 plus 3 divided by 18, and Rp will be equal to 18 by 9, that is 2 ohm. So in series we are getting 9 ohm and in parallel we are getting 2 ohm. So option C is correct. Question number 24. In a circuit shown in figure, the resistor R is equal to 2 ohm. After disconnecting S, the voltmeter reading is 3 ohm. After closing S, the voltmeter reading is 2 volt. So internal resistance R of the power supply. Here the external resistance R is given as 2 ohm, and when the switch is open, that is the switch is disconnected, here the voltage will be equal to EMF, that is 3 volt, and when switch is closed, here the voltage will be equal to 2 volt. So we will use Ohm's law, V is equal to IR. From this we can calculate the current. We will put the value of voltage, that is 2 ohm, and R is equal to 2 ohm is equal to we will find I is equal to 1 ampere. Then we know that the relation between potential difference and EMF, V is equal to E minus IR. And from this, R will be equal to E minus V divided by I. We will put the value of E, that is EMF, 3 minus volt, potential difference V, that is 2 divided by current 1 ampere, and it will become 1 ohm. So internal resistance will be 1 ohm. So option D is correct. Question number 25. A balloon is filled with the idle gas. When the balloon rises, assumes that the volume of gas remains constant and temperature decreases. In this process, the idle gas in the balloon would be. We know that from idle gas equation, PV is equal to nRT. Here, the volume is given to be constant, so we can write P is equal to nR by V into temperature. So this term nR by V will become constant, and we will get pressure proportional to temperature. So when we decrease the temperature, the pressure will also decreases. So D is incorrect. Here pressure is increases. And according to first law of thermodynamics, we know that Q is equal to delta U plus W, where delta U is internal energy and W is work done. Here the change in volume is 0, so the work done by gas will be 0. And we know that in ideal gas, internal energy totally depends upon the temperature. Here, as the temperature decreases, the internal energy will also decrease. So option B is correct. Question number 26. During the ascent of an object being thrown vertically upward, gravity does minus 70 joule of work on the object. Ignoring air resistance, which of the following statement is correct? Since here gravitational force is given as minus 70 joule, and we know that it is a non-conservative force, the mechanical energy of the system will remain constant for non-conservative force, and we know that work done is equal to negative of change in potential energy. Here potential energy is given as minus 70, so it will become plus 70. That means the gravitational potential energy of the object is increased by 70 joule. So option C is correct. Question number 27. If the current passing through a wire is 1.6 ampere, the amount of charge passing through a cross section of wire within 0.5 second is. Here current is given as 1.6 ampere and time is given as 0.5 second. We know that I is equal to Q by T. So Q is equal to I into T. We will put the value of I and T, that is 1.6 into 0.5, which will be equal to 0.8 coulomb. So option D is correct. Question number 28. A certain mass of idle gas with its temperature kept constant and pressure reduced, its volume would be. We know that according to ideal gas equation, PV is equal to nRT. Here the temperature is given as constant, so this whole term nRT will become constant. We will get pressure is inversely proportional to volume. If we reduce the pressure, or if we decrease the pressure, the volume will increase. So option D is correct. Question number 29. 3 point charges ABC are located at the vertices of equilateral triangle with both A and B carrying positive charge. The resultant force of electrostatic force of the two charges B and C acting on A is shown as Fa in the figure. Given that angle between Fa and the extension line of BA is less than 60 degree, what is the correct judgment about the charge C? Here, the net force Fa is shown in the figure. The Fb is the force due to charge Qb, which is in the negative x direction, and for getting the resultant force in Fa direction, the charge on C point should be minus sign or minus Q. And here the resultant force is more towards force B along Fb. So that means the force Fb will be greater than force at point C, and this will be or happen only when the charge at point P is greater than the charge at point C. So option C is correct, that is the negatively charged at point C and charge amount will be less than at point B. Question number 30. As shown in the figure, two parallel metal plates M and N with equal and opposite charges are placed horizontally. The electric field lines between them are parallel lines with the equal intervals, and P and Q are 2 points in the electric field. Which of the following statement is correct? Here, the electric field is shown, and this electric field is uniform, and the direction is shown from N to M. We know that the direction of electric field is from positive charge to negative charge. So the charge on plate N will be positive and the charge on plate M will be negative. So this option, that is the option C, is incorrect. Here M has positive charge and N has negative charge. And we know that E is equal to negative of gradient of potential. That means the electric field or the potential decreases in the direction of electric field, and here the electric field is uniform, so the magnitude of electric field at point Q will be equal to the electric field at point P. I hope you understand each question. Keep practicing, stay consistent, and if you like the video, please share and subscribe it. Thank you.